Hello everyone, welcome back to my YouTube channel. Today, we're going to work on creating and configuring Spanning Tree Protocol or STP using Cisco Packet Tracer. I'll be guiding you step by step through the process to help you understand how STP works and why it's important in preventing loops within a network. So make sure to follow along and let's get started. And now, let's begin by placing all necessary network devices onto the workplace area in Cisco Packet Tracer. This includes switches and PC, and any other components we will need for our STP configuration. Make sure to organize them clearly so that the network topology will be easy to follow as we move on to the next step. Next, let's proceed to connect all the devices in our workplace. Use the appropriate cables such as straight-through cable or crossover cables, depending on the type of the devices you're connecting. Make sure each connection is accurate and properly linked to the connect ports that our network can communicate effectively. Double-check each line to ensure there are no errors before we move on to the configuration stage. Now, let's move on to setting the IP addresses for each of the PC in our network. This step is important to ensure that all devices can communicate with each other properly. Open each PC, go to desktop, then select the IP configuration option. Assign a unique IP address along with the correct subnet mask and default gateway if needed. Make sure that the IP address are within the same network range to avoid connectivity issue later on. Now, let's configure switch 1 to act as the root bridge in our spanning tree protocol setup. The root bridge is the central reference point of the STP topology, and it's important to manually set in ensure network stability and efficient traffic flow. To do this, access switch 1 CLI and enter the necessary commands to assign in the lowest bridge priority. This will ensure the STP recognize it as the root bridge. Configuring this proper helps prevent loop and ensures that the network paths are optimized. And next, let's configure switch 2 as a part of our spanning tree protocol setup. Access S2 to the command line interface and begin by assigning it a hostname, enabling necessary port, and verifying its role in the STP topology. Although switch 1 is set as the root bridge, it is important to properly configure S2 so it can correctly identify the root bridge and determine the best path for forwarding frames. We will also check the port rules such as root port and designated port to ensure the network in preform loops and is operating efficiently. Now let's proceed to configure switch 3. As a part of our network topology, just like with the other switches, we'll begin by accessing the command line interface of S3. From there, we'll set a hostname, check interface status, and verify that it correctly recognizes switch 1 as the root bridge under the spanning tree protocol. We also observed how S3 collect in root port. The port will the best part to the root bridge, and how it handle block or designated port to prevent network loops. This configuration helps ensure that S3 is fully integrated into the SDP structure and that it can contribute to an efficiently and loop-free network environment. And now, let's check the current status of the spanning tree protocol on each switch to verify that everything is functioning as expected. To do this, access the command line interface of each switch and use the appropriate command to display the STP information such as show spanning tree. This will allow us to see important details like the root bridge ID, port rows, and path costs. By reviewing the STP status, we can confirm whether switch 1 has been successfully elected as the root bridge and ensure there are no loops or misconfiguration within the network. The essential step to validate that our topology is optimized and stable. Now let's perform 3 ping tests from the PC to verify network connectivity and ensure that our STP configuration is functioning properly. Start by opening the command prompt from the desktop on each PC in Cisco Packet Tracer. From there, use the ping command to test connectivity to other devices within the network. For example, pinging another PC IP address or the default gateway. Perform at least 3 different ping tests between various PC to confirm that the data can travel across the network without any issue. Successful ping response will indicate that the network is stable, loop-free, and properly configured.